Hello guys, welcome to class 29 of Python programming. We'll discuss indexing, slicing, broadcasting and linear algebra today. This is also class 4 of NumPy. Array indexing and slicing are similar to lists. When it comes to broadcasting, we talk about the arithmetic operation when arrays have different dimensions. I'll take you through some of the images I brought from NumPy website. See this one. Here, this is one dimensional and we have three elements here stored in these indices. So if you see the first index, the element stored is 0. If you see the second index here, this is the index. The element stored is 2. That's fine. Here we are slicing. We are not exactly taking the index, but we are taking a part of the whole array. 0 to 2. When we talk about 0 to 2, 1 will be considered 0th position plus n minus 1. N minus 1 means it will go up to 1. 0 to n minus 1. N is 2 here. 0 and 1. Starting is 0 up to 1. So you get 1 and 2. The elements are 1 and 2. How about this? Starting from 1. 1 means the index 1. The value is 2 here. And colon after colon, here there is nothing. Means everything. Starting from 1, everything. So starting from 1, everything. So you see the elements present 2 and 3. So 2 and 3. This is quite similar to lists. We'll do these things. We'll implement. Now here, if you want to find maximum is 3 here. Minimum is 1 here. If you want to find the sum of the elements, 6 here. These are the ones you will see later. Coming to this one. Here, this is a 2 cross 2, 2 rows and 2 columns. The elements are 1, 2 in the first row and 3, 4 in the second row. Then if you want to find the maximum, here, this is a 3 cross 2, 3 cross 2 array. So if you find the maximum, you write dot max, you will get the maximum of all the elements. You have to consider all elements here. Now similarly, find the minimum, you get 1 here. You find sum of all, you get 21 here. It doesn't matter you have a one dimensional array or a two dimensional array. Come to this one. Here, if x is 0 written, you write max. Within this, you write x is 0. Then you have to find the max of this 5 and max of this 6. You can skip this one, not required. Directly also you can write this way. Remember, you this 5 and 6 you have to write in a row. So that's what you get ultimately. Coming to this one here, x is 1. See this direction. 2 is here. 5 is here. 6 is here. And you have to write in column because x is 1 is there. Next, reshape. If you want to reshape data, 1, 2, 3, 4, 5, 6. 6 elements are here. If you want to reshape, then you can do this way. 2 rows and 3 columns. Here 3 rows and 2 columns. You have to write reshape. This is over. Then this one. np.wants 3 rows and 2 columns. Everywhere you will get 1. Zeros. This is a recap for you. You can remember this way properly. So all are zeros. We have not written specially ARRAY array. So if you write 0, then also you will get the same structure. You write 1 here, all ones, all zeros, then random. But we are here getting 6 numbers. 6 random numbers, not fixed like 0 or 1, but here randomly it will give you. Maybe if you do, you get different numbers. You know that. Now let's go to the next one. Here, this one, if you see, this is 1D. This is also 1D. So if you want to do some operation like addition, suppose 1 plus 2, maybe it's multiplication. Let me write here multiplication. You multiply star here. If you want to multiply 2, if you check 3 elements are here, only 1 element is here. This is called broadcasting. So the other twos, if you can see, automatically you stretch it and make it 2 to 2. Then you multiply 1 with 2, you will get 2 here. Multiply 2 with 2, you get 4 here. Multiply 3 with 2, you get 6 here. If you want to find matrix multiplication, that is dot product. We are not doing dot product here. Remember, this is simple multiplication. We are multiplying element by element. Coming to the second one, that is here. If you check, we have 1, 2, 3, 4 rows and 3 columns. But here only 1 row and 3 columns. So all these things will be copied 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Then the dimensions will be same. It's like stretching this row. So everything will be same. Then whatever you want, maybe this is addition. 0 plus 0, 10 plus 0, that way 20 plus 0, you get all the elements. Then come to this one. Here we have 4 rows, 1 column. Here 1 row and 3 columns. You can stretch this one this way and this one this way. And then if you check dimensions are equal, then you can do operation whatever you want. However, here you can broadcast this. How can you know whether you can do broadcast or not? There are some rules. We'll go through that. Let me create one 1D array. np dot arrange 108 import numpy is np, then let's print a and print (10 to 20). before this one, suppose I want to get access to one element. So let me print that one taking the index. That is indexing. Even I can copy from here. Suppose I want to get the 10th one and then 10 to 20. 108 are here. I have not mentioned rows and columns. For that, I have to use reshape. We'll do that next. So let me run this one. Now, if you check here, starting from 0 up to 107, this is like range function in Python. So here 0 to 107. How many numbers are there? 108 numbers are there. Now, this is a 1D array. Though it looks like a matrix, you might tend to think 1, 2, 3, 4, 5, 6, 6 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, from 0 to 17, 18 columns. 18 columns and 6 rows. But that's wrong because you see, you check here the opening bracket, square bracket, and the closing. This is 1. This is 1 means it's 1D array. Because this much space is available, you don't have any other option but you can see this way. So don't go by that. You don't count number of rows and columns here. We have defined this way. This is a 1D. Also, it confirms from here. The opening bracket is 1 here, closing bracket 1 here. So this is a 1D array. And I wanted to print the 10th element, and I got the 10th element here. So 10th one, you take the index. This is the first index, 0th index, first index, 10th index. I can little bit modify this one also. I can write like this. Now, the 10th element is not 10. If by chance you think, okay, the match and all, they don't match now because I multiplied this by 2. This is also possible. Here you can multiply all the elements by 2. That is possible. Now you check it's 20. The 10th element is 20. So after getting the 10th element, the next task is to get all between 10 to 20. If you want to get all between 10 to 20, you start from here 10. This is called slicing a part. We're taking a part 10 to 19. The starting value is 10 and it will end at n minus 1. So that's how you got 10 to 19. So this is indexing, this is slicing. Taking the index, you got one element and you got a part of the whole list. Then we'll go to 2D array. Now we'll use reshape. This is one way. Using arrange function, you can directly write np.array and you can write the element one by one. That will take time. That's why I'm using this one. Reshape. Nine rows, 9 2. I can write 9 2. 9 rows and 2 columns. or we can make it no, not 9 and 2, 9 and 12, I suppose. Yeah, 9 rows and 12 columns. That's fine. And let's change, print this one. Here 10 is 10 means what? You write 10, suppose this is the row number, and you have to write a column number as well because it's a 2D. So column number, anything we can choose, suppose 5. And here 10, 20 we have written. This is for 1 because it's a 2D array. You have to write a comma and you have to write once again. But will not take 10 to 20, maybe something like 1 to 7 and 2 to 7 or whatever. Then we can run this one. Now this is our original 2D array. Now you can say row and column. Here you can say row and column just because we have one bracket here, one bracket here. If you check, we have two brackets here. Oh, there is some error. Too many indices for array. Too many indices. Okay. Maybe we'll change it to 6. Yeah, most of the time this troubled me a lot. We have to be very careful, attentive. So if I change it to B, then I will get, because A I wrote, it was taking this one. Yeah. Now, 6th row and 5th column. First row, second row, third one here, fourth one, fifth one, sixth one. 6th row and 5th column, 64. 6th row, 5th column. Okay. We'll go to this one, 77. So 5 is here, and you can count from here because this is 0 also counted. So that's why it will be 76. Sorry, 77. Now the next one is, instead of 1, we wanted this. So you check here 1 to 7, comma, means we are talking about this. You can check here 1 to 7. I can use annotation here. Just a minute. Okay. Now 2 times we have to do, that's all. 1 to 7 here. So tick here 1, 2, 3, 4, 5, 6, 7. How about column? 2 to 7? 2, 3, 4. I think this is wrong. N minus 1. This is wrong. 5, 6. Now we can take this one. If I'm not wrong, let's check here. Okay. If you check here, okay, it was like this. We have taken from 2. So it should be, okay, let me clear all this drawing, and I can write like this, because it starts from 2 and it will end 6 at 6 here. You check this one, and this side count here up to 6. 74. This you should get. See, up to 70, 66, 76. Now remember, it's a 2 cross 2. Let me clear all drawing. Cross this. So this is also 2 cross 2. So what we did is, from this 2 cross 2, we got a 2 cross 2 slicing. And we printed 77. We wrote B65. Now suppose, instead of this, I cut this one. Then what? Now I have not mentioned, I have taken the index of the row. I am not mentioned column. You get full row. You check here. This row I got. One row I wanted to take one row instead of one particular element. I wanted one row, full row, from 72 to 83. So if you don't mention this one, you will get this way. Even here we can change a bit. I can go here as well. If you, instead of writing 20, if you don't write anything, then starting from 10 till end means here not the row end means up to 108. If you don't write this side, similar to lists, starting is not mentioned, so you have to start from the first index and you continue till 19. If it's mentioned, that's fine. Also you will come across this. So then this will be your width. Suppose I write 10 to 20, and here with a gap of 2, you run it. Ten to 20 here with a gap of 2, excluding this. So if you have two columns, then this will be the first one, this will be the second one, and this will be the width here. So now width is 2, excluding 20 means it will go up to 18. Now suppose you don't mention this one, then what? You run it. So if you are not mentioning anything, that is equivalent to this. Now let me write this. You don't mention this one. Then if you check, starting is not mentioned and the end is 20 here. Don't see end here. If there are two columns, then don't take the last one as end. So this is the end. I mean, this minus 1. Starting is from the first one, and gap is nothing here. So 0 to 19. Suppose we will not mention this also. Then what? See here, you compare this one with this one. Now, then you cut this one also. Now also check this one and this one. They look the same. So if you want to write all element, this is one way. You can write this as well. Remember, when you are writing 2, this will be the first, this will be the last, of course last plus 1, and this will be the width. This will be like a arithmetic progression. Now suppose I write a minus 1. Let me cut this one. I write a minus 1 here. Then if you check, here I have written a minus 1. So the width is minus 1. Then it will start from the right end, 107. Then with minus 1, this is the last, this is the first, everything, but with minus 1. So from 107, you go up to 0, that way. Even with minus 1, if you want, you can mention, suppose 50, and I want to write 20 here. See, I got here. It start with 50, and with minus 1 it continues, and it will go up to 21. It will not go to this exactly. You can try all this here as well, but remember, you have to write a comma. I can write this way, double here. If you want get all without any width, you write this way. See, the same I got. Let me not print B. This as well. Now I got all the elements here. Because all rows, I've taken all rows and all columns here. Now I can take, suppose I want this one, this one, this one with one gap. I want rows with gaps. Then I can give a gap here, 2. 1, 2, 3, 4, 5 rows. Without 2, how many rows we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 because the last one is not considered, right? So from 0 up to 96, 0 to 11, 12 elements are not there. So the second row is not present here. You write a 2 here. Even first column is there, second column is not there, 1 is not present here. Then this one, then this one, then this one. So width I have taken, and you can mention the first element as well. Suppose you want to start with 3 and you want to end with anything. If you want, you can write, suppose I want to start with 3, end with this one, start with this one, end with this one. That also I can write. Can I write 3 to 30 here? Check here. So I want to start from 3 up to 30 with width of 2. So I have to write print B here. From here we can check. Now you consider rows. Rows you want to start. Although I got an answer here, let's not write this way because it's not there anyway. So it's better I can write 6th or 7th. Then let me run this one. So I have to start from the third one. So if you check here, 0, 1, 2, 3, this one, this row, then up to 7, excluding 7 with a width of 2. So 3, 5, 7 will not come even. So 2 rows I will get. See, 2 rows are here. So you have to copy all and you have to write here. So this will be there. If you want, I can tick. This appears easy. It's easy, but yeah, sometimes it's confusing. So let me write this 36. It's a part. Okay. 36, 37, 38, 39, 40, all this row and this row. Once this is over, you see the column. Column with a width of 2, you have to choose. And nothing is mentioned here, starting ending. So all columns with a width of 2. So this will be considered. So this you will get. And this will not be considered width 2. So these two you will get. Then these two you will get. You continue till getting 46, 70. Because when you talk everything here, starting up to ending mean not mentioned means last but one. Okay, so 46, 70. Up to this you will get all this. Why to leave these two? Let me erase all drawings. Next, let me use this. Copy. Here, 3, 4, 9. That is 108. So I want to make a 3D here, 3D array. And here also I'll make it suppose 1, 2, 3. And the second one is 1, 2, 4. And then the next one, I have to write a comma. Then let me write 4, 2. Whatever. We'll check. So let's keep it this way. Now if I print this one, you see 3 brackets here, 3 brackets here. So the benefit of writing arrange function is you get all elements. If you want to use array, you have to mention all these elements. It will take a lot of time. But remember, 3 frames we have. If you want to draw it, You have to draw 3 frames and you can write all the elements. Suppose I have everything here. I can copy all the elements. Okay, let me go here. Now you can draw this way. This is one frame. This is one frame. Then copy this one. This is the second frame. This is the third frame. Oh, sorry. This is the third frame. This became messy, so let me delete all. Okay, not a problem. Let's not worry about all this. Now we have 3 frames. 1, 2, 3. But index is 0 for this. If you see this way, I can write index 0. Then index 1 here, index 2 here. So for index 0, how many rows we have? We have 1, 2, 3, 4 rows, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 cross 9. This is 4 cross 9. This is 4 cross 9. 3 frames we have. Remember. So if you go here, we have 3 frames. 1, 2, 3. Now, suppose you want to print this. You can print one element also. Suppose instead of this, I write only copy. I write this. Then will you get something? There is a problem, right? So I have to write bracket first of all. B you have to write. Let me run this one. Okay, cut B here. Now run this one. You see, this one also I printed, but here what will happen? B when I wrote here, I got everything. Because when I write this one, this means I've not mentioned this one, these two. So all here also colon means all. That's why you are getting everything. So this 3 you have to write. If you write this way, then what meaning it will take? See here. All all frames, the first one, then all rows, all columns. Then you can mention here like 1 to 3, 1 to 4, 4 to 5, and you check that you are getting this. Now, broadcasting here, let me write from numpy import array. In this case, I need not write a.np, sorry, np.a, because I'm writing this way. Directly I can write a np. I don't need to write np dot array. This np is no more required. I think I said before ap a dot np, something like that. No. np dot array we are writing. This is not required because we have written this way. You have to start with this bracket anyway, and you write a list 1, 1, 2, 3. Then B you can write only 2. Yeah, decimal thing, no problem. 2, 4, 6. So this is called broadcasting. We have 1, 2, 3, but you multiplied with 2. Then B will also be 2, 2, 2. So it will not be changed to 2, 2, 2, but control, let me write here. You should interpret this way: 2, 2, 2. So B. So this is called broadcasting. It will extend in this direction: 1, 2, 3, here 2, 2, 2, that way. So these 2 will be interpreted this way. Then you multiply element by element operation. Multiply 2 with 2, multiply 3 with. You go through some rules. These are the rules of broadcasting. If you go through these rules, although it's not required, with practice you'll be able to know. But yeah, you go through these 3 rules. It says if the two arrays differ in their number of dimensions, then the shape of the one with the fewer dimension is padded. This is called padding, with ones on its leading left side. If the shape of the two arrays doesn't match in any dimension, then the array with shape equal to 1 in that dimension is stretched to match the other shape. Then if in any dimension the sizes disagree and neither is equal to 1, an error is raised. Even the diagrams I showed when I started the class, you can do all those using these 3 rules. Now let me change this. Suppose a is equal to array this is 1. Let's copy and change this to 10. and 30 here. And B is 1, 2, 3, 4, suppose. Now, if I want to print A plus B, so if you check here, all these elements are added to this, and all these elements are added to this, and then this, then this. So let's apply the rule here. I can use annotation. So the dimension, you write the dimension here. How many rows you have? If you print, you will be able to know. Even you can print the dimension also if you have doubt. 1, 2, 3, 4. And how many columns? 4 rows, 4 columns. How about this? This is 4 like this, right? If you want, you can print it because it's 1D, it's not 2D. Then what will happen is you have to write a 1 to the left. That is the rule. Then anyway, they are matching. So what will happen is if this is 4, this will become 4. That is called broadcasting. So 4 times. This will be repeated 4 times. And then everything will be available and you can do that. But remember, if they're equal, if these two are not equal, then you can make it 4. That is what we are saying. Even you can try with some other 3 dimensions so that there will be, greater clarity. You can try 1 or 2, but it's easy. You can do the diagrams. Let me clear all drawings. Now we'll try to solve system of linear equations. Let me write 3 equations here. I want to solve 8x plus 3y minus 2z, suppose, 9, then minus 4x plus 15y plus 35z is equal to You will get, okay, anything. Integer solutions, if you want, you have to think. Okay. 3x plus 4y plus minus 12z. I'm not sure whether we'll get integer solutions or not, though. In any case, it's difficult to think this way. I tried, but yeah, that might not be possible. Let's check. Instead of solving manually, we'll write capital A here. NP dot array. You collect all the coefficients. 8, 3, minus 2. Copy, paste here. And then you can change minus 4, 5, and then 3, 4, minus 12. Later you see, you will be able to know why we write capital letter. Never mind, this is the symbol we use when you have more than in machine learning. We use capital and small. We have more there. And the coefficients, if you collect 9, 15, 35, you get this way 9, 15, 35. I thought some way, I'm not sure whether we get integer solutions or not. So you are solving system of equations. Ax is equal to b. A is collection of the coefficients. We have written like this, 3 rows and 3 columns. But this is a single array, 1D array, B. Then we'll solve. You have to remember the answer will be np dot we'll use later these equations. LINALG. Even we'll use sklearn. There also we have lot of mathematical functions. Here if you want, you can check numpy. In numpy you will get this one. That's how we write this way. And you will be able to know why we write dot once object-oriented programming is over. Again, you will be able to know. You can check this is available. Okay, we have to print x. Yeah, I didn't get the integer solution, but yeah, you can check. You can put x, y, z, and you can check that the three equations are satisfied. So if you want, you can check numpy. This is available. Don't want to stretch the class, and I want to end numpy classes 1, 2, 3, 4, 4 classes with this. We have a little more. Maybe those things will come when you go to machine learning and pandas even. So there will come across little bit more. However, I want to end classes of NumPy with this. Thank you. Class is over now.